Told you you're going to need that formula, didn't I? Because this time you don't know what lambda is. You've been told that the probability that x is equal to 2 and the probability that x is equal to 3 are both the same. So the formula is e to the minus lambda times by lambda to the x, which here is 2, over 2 factorial. And that's going to equal e to the minus lambda, lambda to the x, which this time is 3, over 3 factorial. Now clearly we can cancel the e to the minus lambda on both sides, because it's on both sides. We can also cancel a lambda squared. Lambda can't be 0. This is the average number of occurrences in the time frame, so you couldn't count, there couldn't be an average of none of them, because then you're never going to get 2 of them. So we're going to cancel a lambda squared with one of the lambdas. So then I've got 1 over 2 equals lambda over, now 3 factorial is 6, times both sides by 6. I've got lambda equals 3. So we've got the algebra there. Now stay watching, because I'll blow your mind with this, that the calculator can actually do this. Really quite exciting. I only found this out recently. So if we go into our options and we go to our calculations here, and I want to solve n, and the solve n I'm going to do is a distribution of Poisson. I'm doing a PD, and I want the Poisson of 2, but I don't know the mean. And I want that to equal a Poisson with x is 3, and I don't know the mean. And I want it to find the mean. Now I've tried this already, and it gives the right answer. Then it gives some massive answers that have basically gone off the top of the range. So we'll just go from 0 to 100 for our range of different x's there. And you push execute. It thinks about it for a while. It then says there might be more answers, but we don't want it. There, look, it tells us the answer's 3. If I didn't put the bit on the end there, the range of values, I just said, look, find out what x is. It then takes even longer to do it, and it ends up finding, finds out 3, but then it finds out loads of numbers. So there's the 3, but then it gets loads more answers, these big, over 252. And I think when you're looking at here, e to the power of minus 252 here, we must be sort of maxing out its memory, trying to think something's happened at that value that means it now thinks that there's loads more answers. But isn't that clever? Solve n can work